Good morning, class. Today in JSS 2 Basic Technology, we are studying the properties of materials, specifically strength and hardness, along with related properties that engineers use to select the right material for the right job. Every material used in technology, whether metal, plastic, wood, or concrete, has specific properties that make it suitable for certain applications and unsuitable for others. Understanding material properties is fundamental to engineering design. Let us begin with strength. Strength is the ability of a material to resist forces without breaking or permanently changing shape. There are several types of strength, each related to a different type of force. Tensile strength is the ability of a material to resist being pulled apart or stretched. When you pull on a steel rod or a rubber band, you are applying a tensile force. Steel has very high tensile strength, this is why it is used in bridges and building frames. Concrete, on the other hand, has low tensile strength, it cracks easily when pulled. This is why concrete is reinforced with steel rods, combining concrete's compressive strength with steel's tensile strength. Compressive strength is the ability of a material to resist being crushed or compressed. Concrete and stone have very high compressive strength. This is why concrete columns are used to support buildings, the weight of the building compresses the columns, and concrete resists this perfectly. Shear strength is the ability to resist forces that try to cut or slide one part of the material across another. Bolts and rivets must have high shear strength because forces try to slide the joint apart. Torsional strength is the ability to resist twisting forces. Drive shafts in engines and cars must have high torsional strength. Bending strength, or flexural strength, is the ability to resist bending forces. Floor beams and tabletops must have good bending strength. Now let us study hardness. Hardness is the ability of a material to resist scratching, indentation, or penetration by another object. A hard material is difficult to scratch or dent. Diamond is the hardest known natural material, it can scratch any other material. Mild steel is harder than copper, which is harder than aluminum, which is harder than wood. Hardness is tested using standardized methods. The Brinell hardness test presses a hard steel ball into the surface of the material under a known force, then measures the size of the dent. The smaller the dent, the harder the material. The Rockwell hardness test uses a diamond cone or steel ball and measures the depth of penetration. Now let us look at other important material properties. Elasticity is the ability of a material to return to its original shape after the deforming force is removed. A rubber band is elastic, stretch it and it springs back. Steel is also elastic within limits, this elastic region is important in spring design. Plasticity is the opposite of elasticity. A plastic material permanently changes shape when a force is applied and does not return to its original shape. Clay and lead are plastic materials. This property is used in metal forming, bending and shaping steel uses its plasticity. Ductility is the ability of a material to be drawn out into thin wires without breaking. Copper is highly ductile, this is why copper is used for electrical wires. Gold is also very ductile. Malleability is the ability of a material to be hammered or rolled into thin sheets without cracking. Gold and aluminium are highly malleable. Gold can be hammered into sheets so thin that light passes through them. Brittleness means a material breaks suddenly without bending or stretching. Cast iron and glass are brittle, they snap without warning instead of bending first. Brittle materials are strong in compression but weak in tension. Toughness is the ability to absorb energy and resist cracking or breaking when struck. Tough materials can absorb sudden impacts. Mild steel is tough, this is why it is used for tools that must withstand hammering. In Nigeria's engineering industry, choosing the right material for the right job depends on understanding these properties. Bridge girders must be strong and tough. Cutting tools must be hard. Electrical cables must be ductile. Building columns must resist compression. For your examinations, be able to define each property, give examples of materials that have each property, and explain why each property is important in engineering applications.